Oh my god, is that a real key? Oh shit, it is.
How to submit a bug bounty. 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 How to submit a
Hello, cktivityCon. cktivityCon? 4 years ago, I open sourced TruffleHog, a tool that finds secrets in source code. Today, I'm happy to open source another tool that finds secrets in a different type of source code. TruffleHog, the Chrome extension, is a tool that finds secrets in HTML and JavaScript in the websites you browse. Here's a few examples of keys leaking out this way. You want to start by introducing yourself?
I can. How do you want me to go? Do you want me to be like, hey, I'm a friend of Dylan's, or hi, I'm a security engineer? Scary stuff in the world.
Just the more you fumble, I'll include those fumbly bits.
Okay, all right. This will just be me.
As you'd like to be presented.
All right. Hello. My name's Mike. I am a security engineer currently at Brex on the infrastructure security side of things. Before that, I was in sort of a product security space at VMware.
So you know nothing about this talk, right?
Whether you're asking if I know what the topic is or if I am a subject matter expert of the topic, the answer is probably no to both.
Probably one of my favorite examples of keys that I found using this Chrome extension was a key that I found on the front page of weather.com, which we can actually still view on archive.org. If we view source, there it is, surrounded by some other keys sitting right on the front page of a website that's viewed by millions of people every day. So I'm going to screen share something with you.
That's a key that of theirs, not belonging to me as like sort of a client or browser of the site, but something they accidentally kind of slipped in there that could probably be used for accessing something that we shouldn't.
Here's another example of a Slack key that I found in the front-end JavaScript of a single-page application. So why is this so common? Why are keys making their way into the front ends of popular applications? The answer might surprise you. Many SaaS applications are actually built in a way that encourages front-end applications to contain keys in their JavaScript. Most of these keys aren't accidents and aren't in observable text blocks that are meant to be shared. They're actually being used by the JavaScript on the page. That's because APIs like AWS and Slack have architected themselves to be open to cross-origin resource sharing, inviting websites like weather.com to integrate with them client-side.
Browser protections to go from one website to another. Well, there's there's like a cross-origin resource policy and stuff like that, right? Which kind of prevents you from being able to grab things from one domain and use it in another.
Just to recap on cross-origin resource sharing, one of the most fundamental browser security policies is the same origin policy. Basically, if you're on one website and that website serves you JavaScript, the JavaScript on that page allows the browser to make requests and view responses to and from that website. But by default, it can't make requests and view responses to any other website. website without explicit permission from those other websites. This is what allows you to browse google.com without having to worry about Google forcing you to send requests to Facebook and stealing all your Facebook data behind the scenes. These origin sandboxes help protect you, but what happens when one website wants you to be able to make requests to other websites? This is where cross-origin resource sharing comes in, or CORS for short. If a website includes an access control allow origin header, it could specify another origin that's allowed to make requests to it and view the responses. So if you visit one website and you make a request to another website, if that other website responds with an access control allow origin header with the website in question that you started on, then the JavaScript on the page can make requests and view the responses from that other website while you're browsing the first website. You might have noticed how I said the header can allow you to specify one origin. That's kind of true, but there are actually two ways that you can run cross-origin resource sharing in an extremely permissive way that allow any websites to make requests and view responses instead of just a single origin. The first way is with a wildcard. When we set our CORS to wildcard, we allow any website to be able to make requests and view responses, but we still get some built-in browser protections. Notably, these cross-origin requests do not include cookies, regardless of the cross-origin resource sharing policy for cookie sharing. The second, more dangerous way is not actually a way built into the browser spec. It's kind of a hack that a lot of libraries have adopted. Basically, when one website makes a request to another website, if it pays attention to where the request came from and mirrors it back into the access control allow origin header, this allows for open CORS sharing from any website. This is a much more dangerous method because it basically gives up all of the protections that the same origin policy affords you. Both of these CORS settings are extremely common in APIs. You might be able to figure out why. APIs are designed for other services to consume them. As a fun aside, it's actually really common for internal apps to be built with access control allow origin headers. This is because these days applications are typically built to be API first, and because of that, that naturally led to multiple services wanting to consume the same API. The lazy way to set this up is to just simply allow any service to be able to consume this API. There are also some interesting politics at play. When you work for a large company, often the way the incentive structures are set up, you want your service to be consumed by as many teams as possible. This is so that when your performance review comes around, you can boast about how your service has all this adoption and usage.
We just want to get as much adoption as possible because that looks good. But you know, alternatively, maybe it's we want to get as much adoption as possible because this is an important service, and then we'll go back in and tweak it, and maybe it never happens, and that's kind of where some of the problem comes.
If you put individual origin restrictions into your service, this slows down the adoption of your internal service. So we find it common that internal services often access control allow origin wildcard or access control allow origin reflect back the origin header. You might think that that's not a big deal if the service is internal, but actually that makes it a lot more dangerous than if the service were on the internet. This is because in addition to allowing internal services to be able to access these resources cross-origin, external services can also access these services cross-origin. That means if you browse to an evil website and the evil website has JavaScript on the page coercing you to send a request to an internal website, as long as you're sitting on the internal network, the browser doesn't really know the difference between the networks that you're straddling, and that evil website can force you to make requests and steal the data that's served by the internal website.
I would say 99% of people aren't even thinking that that's a use case that they need to consider.
What this means is if you're doing a lot of reconnaissance for a given company and you find yourself running into a bunch of domain names that you suspect are internal domains because you can't access them and maybe they have a 10. IP address, if you have a pretty good relationship with the program, you might be able to construct an evil HTML file that makes requests to all of these internal services. Then you could try poking the bug bounty managers of the program and ask them to run your HTML page. If you're lucky, they'll say yes, and if you're extra lucky, the HTML on that page will be able to make requests and view responses from at least one of the services that you found during recon. This enables your evil HTML to be able to steal data from an internal app that it shouldn't be able to. More often than not, at least one of those internal services will be configured this way, and you might be able to make some bug bounty money by exfiltrating internal data that you're not supposed to be able to access. Okay, popping stack way back to the Chrome extension. The reason these API keys are leaking out is because these APIs are often constructed in a way that encourages foreign origins to be able to make requests to them. This leads to API keys being included in static resources such as HTML and JavaScript. Let's take a look at Amazon's API to see how they did this. We can see when we include an origin header, Amazon's API responds with an access control allow origin wildcard. This more or less invites websites to include Amazon keys in their static resources so that they can make requests and view responses to Amazon. Oftentimes, these keys are compiled directly into JavaScript. The reason being, you can build an entire application stateless without a backend server if you're interacting with Amazon APIs and those Amazon APIs are functioning as your state, like saving data in S3, for example. It's a lot less overhead, but obviously comes with some security concerns. Amazon is essentially encouraging front-end JavaScript to make requests to this API, and because their API requires authentication, we end up with some Amazon keys in some weird places.
Well, so like I'm trying to think, like, are we interested in trying to disparage this pattern?
I mean, I think they must have known what they were doing, right?
Maybe not so much looking at these security use cases or implications, one or two sort of steps downstream.
In addition to Amazon and Slack, we found a number of other APIs that are also configured with permissive CORS settings, encouraging front-end JavaScript to be able to interact with them. This includes Mailgun, IPstack, and a bunch of other services. So now that we've established why these keys are there, is it a bad thing? Does it matter if these keys are leaking out? Are they meant to leak out? Well, I think the short answer is yes, it does matter. If these APIs are constructed to require API credentials, and these credentials don't have any authentication on them, we've lost something. What that something is can often vary dramatically. It might be as simple as rate limiting. If the API key is meant to restrict how many times an individual user can make a request to a given API, there's the denial of service opportunity for an attacker to take this API key and hammer the API with way more requests than you're expecting. Another simple use case could just be a money attack. These APIs are often set up in such a way that every time you make a request to them, it bills you a little bit. And while you might be expecting a low volume, if your keys are just sitting around in your JavaScript files, you can't really prevent someone from taking these keys and hammering the APIs with way higher QPS than what you're expecting.
Well, first thing is a write is going to cost them something, right? So you just keep writing and writing, and that bill's gonna go up pretty steadily depending on how much you're writing. So that would be my first thought.
Maybe you're preparing for 1 or 2 QPS per second. An attacker could take that and jack it up to 1,000,000 QPS in a given second, and you could end up with a ginormous Amazon bill that you're not expecting. These are some of the light use cases for what you can do with these keys. Let's take a look at some examples that are more serious. It's very easy to over-permission an Amazon API key.
Well, I'd say a third use case that I'd add on there is someone just sort of following directions, right? Where they looked up a Stack Overflow or something along those lines, and they just copy-pasted a set of permissions into the policy because they read it somewhere, and that's, it wasn't uniquely tailored to whatever it was that they were trying to do.
It's also extremely common for a developer to do development with a key that has a certain set of permissions with the intent of scoping that key down after they roll it out in production. The problem becomes when the descoping never happens for one reason or another. That reason could be that the developer rolls off the project and someone else takes over without all the context, or it could be the developer just forgets or gets too busy and becomes distracted with another project. One specific example could be that you build a front end that's meant to interact with an SQS queue, and maybe you only want it to publish to a certain SQS queue and do nothing else. You could imagine problems with someone taking that key and publishing large volumes of data that you're not expecting onto that queue, but what if the key was accidentally scoped to also be able to read from SQS queues? Or what if the key was accidentally scoped to all SQS queues and it allowed the attacker to publish to different queues? We've seen both of these use cases pop up, and you can see from looking at the policy file why a developer might be tempted to overscope the key, at least while they're doing their initial development. Another really common use case that we've observed is a developer might end up using their own administrative key for their initial testing, and the administrative key might be able to do literally everything in the Amazon account. This is certainly the easiest way to develop the application. You don't have to worry about the permissions at all, and the developer just expects that at some point in the future they'll just figure out what the specific permissions are that they need and they'll descope the key. But they don't want to be slowed slowed down in the meantime while they work on the application. Then that developer might leave the company, they might leave the team, they might end up just going on sabbatical, another developer comes along, and they don't have the context that the original key is fully administrative and needs to be descoped. So you end up with a fully administrative API key sitting in a JavaScript file that gets served without authentication to the public internet. Also, think back to the earlier example when I mentioned that there are internal applications that you can make requests and view the responses to. Many of those internal applications have more AWS keys than the external applications. This is because people assume the apps are internal and won't be able to be accessed. But if they're set up with permissive CORS, an attacker can make a request and view the response to the JavaScript of the internal application and steal the Amazon key that's supposed to be able to make requests and view responses to Amazon. And just like that, you can chain multiple CORS problems together and get access to keys you're not supposed to be able to get access to. Let's look at the Slack example. In this example, the developer built the contact us page to be completely stateless. The way they did that is if you visited the contact page and you filled it out, all of your information would just be sent directly to a Slack channel via a Slack API token. This way, the application doesn't actually need a backend to process the result from the contact us page. It's a clever way of architecting the app. Unfortunately, it comes with some security issues. Notably, these tokens that are advertised from Slack as being able to post to individual single channels can actually be abused to post to other channels. Here's a blog post detailing how that's possible. But the long story short is this credential will be created under sort of a false pretext that it'll only be used to post to a single channel, when in reality you can post to almost any channel you want with it. In addition to that, you could imagine that there's some post-processing happening in the JavaScript to structure the message a little bit. Well, obviously, if you extract the key out, you can override that post-processing and structure the message however you want, which could enable you to upload malicious attachments or do other nefarious things that the recipients of the Slack message aren't expecting. As single-page apps become more and more common, and as SAAS integrations to these single-page apps become more and more common, I think we can expect this trend to grow over time, that keys leak out in client-side applications. And I think this trend is unlikely to reverse. We can probably expect more and more single-page applications to leak out keys and credentials that traditionally we would expect to see in back-end application code. That's why the Chrome extension helps you identify these keys, so you can test out these use cases and figure out if there's security issues. I want to talk about one other type of API key that's really common to leak out, and that's actually keys that are intentionally leaked out. These are the kinds you expect with analytics scripts. Scripts that are designed to be able to give simple metrics about who's viewing the website and how many people are viewing the website. These analytics scripts are often built by SaaS providers that definitely intend for these keys to go into client-side application code. And usually it's not a big deal, but it's worth noting that these APIs often have a different set of endpoints for administrative keys. In other words, keys to these websites are divided into two camps. Keys that are meant to collect metrics and are meant to be sent client-side, and keys that are administrative and are meant to edit analytics collection and do other things that you wouldn't want client-side. However, because the API endpoints often use the same origin as the public API endpoints, sometimes you end up with access control allow origin headers on both the administrative endpoints and on the public endpoints. And that, in many ways, encourages these administrative tokens to also be sent client-side. So in the README, I've posted several examples of analytics APIs where you can take an analytics token and very quickly test to see whether or not it's an administrative token or a token that's meant to be public. Another super interesting use case that comes up a lot are Google API keys. These keys are used for interacting with Google Drive, Google Calendar, Google Maps, YouTube, and more. There's plenty of legitimate use cases for these keys, like including Google Maps on your website, but they're very easy to overscope and include extra permissions that you don't want. For example, just within Google Maps, here's a link to a resource that allows you to take a Google Maps API key and see what it has permissions to, and you'll see that even within just Google Maps, you can over permission these keys.
If credentials are undeniably going to be ending up in front ends, can we scope that down to be very specific on what it is that needs to be done?
It would be nice if we actually had a tool that could take one of these keys and test it against all of Google's APIs, so you could quickly take a Google API key and see what it has access to. I couldn't find a tool like that, but maybe if somebody's interested in either extending the Google Maps tool or creating another tool, that'd be pretty cool, and it would be much easier to sort out whether or not these Google API keys that are all over the place are issues or not.
We got it.
I also included a few more features that could help you find leaky keys. The first is an optional check for .git directories. It's really common for developers to accidentally expose their .git directory when they host a website. This is because the directory where they do their development out of often contains a .git directory, and often they'll just copy everything in the current working directory over to a web server, which of course includes the .git directory. There's a ton of blog posts explaining why this is so common and what the ramifications of accidentally leaking your .git directory are, but at a high level, it basically leaks all of your revision history for your project. You can find instructions on many of those blog posts for how to download all the contents of the .git directory. And then once you've downloaded it, you can actually run TruffleHog on that .git directory and search the application's backend code for secrets and credentials. Every single time I've looked through the Alexa 1,000,000 for leaky .git directories, I've found hundreds of examples of websites that have their .git directories exposed. Here's an old DEF CON talk from a couple years ago about it. It's nothing new, but it seems like this problem isn't going away anytime soon. Similarly, I added a check for environment variable scripts. Just like the .git directory, sometimes developers will have environment variable scripts in their working directory when they copy all of their files over to their web server. And of course, environment variable scripts are going to have lots of secrets in them. The downside of these checks is when you check for .git directories and environment variable scripts, firewalls often detect this activity and block you. So you may want to be careful about how you use them. And if you see a bunch of 400 errors, then you probably have to turn off the .git directory and environment variable checks so that you can continue to test. Another interesting thing here is that since the advent of microservices, it's actually not uncommon to have .git directories several paths deep on a given website, and tools like dir search will often only search the root directory for .git and environment variable scripts, and this misses a lot of opportunities for leaky .git directories and environment variable scripts. So the Chrome extension will actually search the path of whatever you're currently browsing. That way, if a microservice is hosted on a path of a website that you're browsing, you'll be able to check that path as well for .git directories and environment variable scripts. Okay, finally, there's a few limitations of this Chrome extension that I want to walk through. Notably, I couldn't actually find a native API to be able to introspect every single request and response to and from a front end and a back end. This means right now, the Chrome extension actually reads out the current document tree, parses all of the JavaScript links, and then refetches all of those static assets for scanning. This isn't great for performance because it means static assets are basically loaded twice, and it also misses a lot of keys that are transmitted over JSON APIs. I believe it's actually possible to do this kind of scanning with a service worker, since service workers are able to introspect requests and responses to and from a server, but I haven't really looked into injecting a service worker with a Chrome extension. I think it's possible though. Another limitation is there's currently no caching. If you go to a website, it will scan the jQuery on that website, and then if you view another website or the same website again, it'll refetch the same jQuery and scan it again. It would be a nice performance boost if it had some memory of things that it's already scanned before. If anyone would like to contribute or improve these limitations, here's a link to the repository for the code. Lastly, if you use this Chrome extension to find keys that you submit to a bug bounty and you want to do me a huge favor, give a shout out to the tool. This helps other people learn about it. Thanks so much and happy hacking. Hopefully this helps some people find some keys in some pretty gnarly places. Okay, quick epilogue here. I shot this footage later. Remember earlier in the video when I mentioned that you can still view the keys on weather.com that were remediated through archive.org? Well, it just dawned on me that you might be able to scan all of archive.org for all kinds of keys that were historically just leaked out in front ends and then committed over the top of. This is actually one of the main reasons I open sourced the original TruffleHog, was to go through and scan all of the old code in the repository that wasn't currently being checked for keys. So if you're testing a website, it might be interesting actually if you went through all the old versions of that website on archive.org with the Chrome extension. You can probably find some keys that are buried back there. And if you work at archive.org or know someone that works at archive.org, let's get in touch.